Hello, and welcome to our podcast. My name is April Rose Peshniak, and today we're going to be looking at task analysis. So, what is it? Task analysis is an evidence-based practice. Here we have two different definitions of task analysis. Task analysis is the process of breaking a skill into smaller, more manageable steps in order to teach the skill. As the smaller steps are mastered, the learner becomes increasingly independent in his or her ability to perform the larger skill. The second definition says, a task analysis is used to break complex tasks into a sequence of smaller steps or actions. Both definitions are basically saying that task analysis is the breakdown of a single task into the various steps that make it up, or the how-to steps needed to complete a particular action. For most of us, the tasks of tying a shoe, brushing our teeth, or getting dressed come naturally, but for others, more help is needed in learning these life skills. So, who can benefit from task analysis? Why use it? Task analysis is used to make harder activities more accessible for those who cannot complete them easily. Students can work on and master one small task at a time instead of trying to take on the whole task at once. Task analysis can be used for any skill that can be broken down into smaller steps, including academics, behaviors, communication, and social skills. For educator purposes, task analysis is often used with individuals who have autism spectrum disorder, an intellectual disability, or for normally developing young children needing extra guidance to learn a new skill. So where is task analysis used? Task analysis can be used in the home, at school, and in the community. We see examples of task analysis all the time in how-to books and in directions. How-to books break down complex actions into simpler, smaller steps, the same way that directions and manuals tell you how to put together a new table, install a car radio, or bake a cake. Driving directions may be basic, such as turn left on Wilbur Avenue, or they may be given more specifically, such as take your third left onto Wilbur Avenue by the big red house. This all depends on who we are giving directions to and how much assistance they need. Some people might need to see a map, and we would include pictures. All these modifications can be made when altering an already created task analysis to fit the particular student being worked with. So how can we use task analysis beyond teaching life skills in the classroom? Pause the podcast to think about what types of specific tasks might be taught using task analysis in the classroom. These are just a few I thought of, but there are many ways that task analysis can be used in the classroom. We might use task analysis to teach how to walk in the hallway, how to complete the morning routine in the classroom, how to complete the pack-up routine in the classroom, how to explain the different class jobs. Each job might have a checklist of required actions that students follow. How to throw away trash in the cafeteria, or how to buy a school lunch, or even how to teach basic addition. It is all about what works for you and your students. The steps may need to be modified. Pictures may or may not need to be included with written steps. Every student is different, but if there is a task that a student is struggling with, then a task analysis might be useful to break it down. Now some of you might be saying, addition? Yeah, all right. I see how the other ones would work, but how is addition going to be taught through task analysis? We will come back to that in a little bit, but first, let's now move on to how task analysis is executed. So now we know what task analysis is, but how do we teach it? This can be taught through chaining, prompting, and reinforcement. There are different types of chaining that might be used: forward, backward, and total task presentation. As you can see in the diagram, there are also different types of prompts that can be used to help the students learn each individual task. The prompts on the top are the least intrusive prompts, and they increase as you get to the most intrusive prompt at the bottom, the full physical prompt. We'll come back to describing each of the prompts a little bit more in depth. Reinforcement is also used to help the students realize his or her accomplishments and to know when something is executed correctly. Reinforcement will differ depending on the individual student. That is a whole separate topic, but the main thing to remember here is that reinforcement is essential if we hope to increase the likelihood of a behavior. Let's go back to chaining for a minute though. Now some of you might be saying, well, wait a minute, I've heard of chaining. Isn't that basically the same thing as task analysis? They are related, yes. The different written steps or chains are combined to create a task analysis for a particular activity or task. So chaining is the set of teaching procedures used to teach the different steps of a task analysis. Again, there are three types of chaining: forward, backward chaining, and total task presentation. Forward chaining is when the steps are taught one at a time sequentially. The student would complete the first task with assistance and be reinforced when it was completed. Then, the teacher or whoever was working with the student would complete the rest of the steps for the student. Once that step was mastered independently, more chains or steps are taught to the student. All taught steps need to be completed before reinforcement is given. The benefit of this method is that students learn the logical sequence of the steps required to complete the task because they are learning the first step first and moving forward. Backward chaining is the same thing, except the student is focusing on learning the last task first. The teacher, aide, or parent would complete the other steps for the student until they got to the final step. When the last task is mastered, then the next to last task will be introduced to the student, and both steps must be completed before the reinforcement is delivered. It is important to realize that the steps are not being completed in reverse order, but that the student is gaining responsibility of the steps from the last one back. The benefit of this form of chaining is that the student gets an immediate sense of accomplishment for finishing the last step on his or her own. The benefit of the task is apparent from the beginning learned step, and there is a feeling of satisfaction. Total task presentation is a variation of forward chaining, where all the steps are taught at once to the student. The student is reinforced after the completion of each step, with the strongest reinforcer provided after the completion of the last task. Eventually, the reinforcement must be faded so that the student may successfully complete every step to complete the task independently. This might be used in math in the classroom when students need to learn to add, subtract, multiply, or do long division. It wouldn't be beneficial for students to only complete one step at a time in those instances. This form of chaining is beneficial because all of the steps can be taught without interruption. Additionally, any steps that are mastered can be completed independently along the way. One caution that comes from this form of chaining is to be careful that the student does not become dependent on the constant reinforcement and prompts. The research is unclear as to whether or not one chaining procedure is better than another. It is important to remember that each student is an individual. You might need to try out all of the different types of chaining to see what works best for the student. Prompts are very useful when teaching any new task. Students won't automatically know how to complete each step in the task analysis. If they did, then they wouldn't need this breakdown. Each step can be taught with prompting. A gestural prompt is the least intrusive prompt you can use, besides the student receiving a natural cue. If you want the student to put away his backpack, then a gestural prompt might be to point to the backpack and then point to the closet where it needs to be hung. A verbal prompt would be telling the student, please put your backpack in the closet. A visual prompt might be a picture of the backpack hanging in the closet. A modeling prompt would require the teacher to physically model taking the backpack and hanging it hook in the closet. A partial physical prompt would use some hand-over-hand help, perhaps just picking up the student's hand and putting it on the backpack. A full physical prompt would require hand-over-hand for the duration of the step, picking up the backpack, walking to the closet, and hanging up the backpack. You have to be careful with prompts, especially verbal ones that get used all the time. Students can become dependent on prompts. It's important that they are faded and the student can complete the task independently. So when should you move on to the next step? Most of the time, a task is considered mastered when it is completed accurately 80 to 90% of the time. This may be 4 out of 5 times or 8 out of 10 times, whatever seems necessary for the student to show mastery. I have also seen skills determined to be mastered when they are executed flawlessly in 3 different consecutive occasions. So a step is mastered. Then what? It is time to then teach the next step in the chain if you're using forward or backward chaining. If you opted for total task presentation, then you can continue to focus on the steps that are not yet mastered. When possible, it is also beneficial to generalize the task to other locations. While you might not brush your teeth while out at the park, a child can tie his or her shoes in various different locations. Finally, though it might seem redundant, it is important to periodically revisit the skills to ensure they are not forgotten and are still considered mastered. That concludes part 1 of our presentation on task analysis. Please watch the next part, Task Analysis Part 2, to see how to actually execute a task analysis and review some specific examples of task analysis. I look forward to seeing you there.